Hello everyone. In this video, I'll be presenting two artifacts that I developed using Python and data-driven technologies. First, I'll begin with Artifact 1, Data Visualization using Python, titled Global Energy Consumption Analysis. The objective of this project was to analyze global energy consumption patterns and explore relationship between different energy sources using Python visualization libraries such as matplotlib and seaborn. For this project, I used a real-world dataset containing global energy consumption statistics across multiple countries and years. The dataset includes information related to oil, gas, coal, solar, wind, renewable energy usage, GDP, and energy consumption per capita. To begin the project, I firstly imported the required Python libraries such as pandas for data handling, matplotlib for plotting graphs, and seaborn for creating more visually appealing visualization. After that, I loaded the dataset into Python using pandas. I then performed basic data cleaning by checking for missing values and removing incomplete records from important columns. This step was necessary to improve data consistency and avoid errors during visualization. Next, I started generating different visualizations to understand the dataset. The first visualization is the bubble chart showing oil consumption by country. In this code, I used the group by function to calculate the average oil consumption for each country. Then I sorted the value and selected the top 10 countries before visualizing them. This chart helps quickly identify countries with highest oil usage. The second visualization is line graph for global gas consumption trends over time. For this graph, the dataset was grouped by years and the average gas consumption was calculated. The plot function was then used to visualize how gas usage changed across different years. Next, I created a scatter plot comparing solar and winter energy consumption. In the code, I used seaborn scatter plot function to compare two variables directly. This helped observe whether countries with higher solar energy usage also tend to use more wind energy. I also created a radar chart comparing major energy sources such as oil, gas, coal, solar, and wind. For this visualization, numpy was used to generate angles for radar structures, and average values were plotted to compare overall energy dominance globally. Another important visualization in this project is the heat map. The heat map was created using a correlation matrix generated from multiple energy variables. This helped identify a relationship between different forms of energy consumption. I then created a regression plot comparing GDP and energy consumption per capita. This visualization helped explore whether countries with stronger economies generally consume more energy. Next, I created an area chart showing renewable energy growth over time. The code grouped renewable energy variables such as solar and wind and hydro energy by year and then visualized the gradual increase in renewable energy adoption. Finally, I created a bar chart showing countries with the highest renewable energy consumption. This helped compare renewable energy usage between countries. Overall, this project helped me better understand how data visualization can simplify large dataset and communicate insights more efficiently. One of the strengths of this project was to use multiple visualization styles instead of relying only on basic charts, which improved both creativity and storytelling. However, there are also some limitations such as missing values in the parts of the dataset and the use of average values which may not fully represent yearly functionalities. In the future, this project could be improved further by adding interactive data dashboards using tools such as Plotly or Power BI. Now I am going to present my chatbot development project called Smart Energy Diagnostic Assistant. This project was developed using Python and Google Colab as part of the chatbot development artifact. The main goal of this chatbot is to help users identify common household electricity consumption issues and provide recommendations for reducing energy usage. The chatbot also helps users better understand electrical usage pattern in daily life. This project meets the required chatbot development criteria because the chatbot responds to user queries, includes more than 5 conversational intents, provides structured responses, and demonstrates a practical, real-world application scenario related to energy awareness. Now I'll explain how the chatbot was developed. First, I created the chatbot knowledge base using a Python dictionary called Energy Intents. Each intent contains keywords and predefined responses. The chatbots include several intents such as greeting, high electricity bill, AC usage, lighting, appliances, energy saving, standby power, peak usage, smart tips, and goodbye responses. For example, if the user types words related to AC or cooling, the chatbot identifies the AC usage intent and returns appropriate response about energy efficiency, air conditioner usage. This structure allows the chatbot to provide organized and relevant answers. Next, I implemented the response processing system using the getResponse function. Inside this function, the user input is first converted into lowercase to improve keywording matching accuracy. Then the program loops through all the intents and checks whether any keywords match the user's message. If a matching keyword is found, the chatbot returns the response from the corresponding intent category using the random choice function. If no keyword is matched, the chatbot displays a default response asking the user to describe their issues more clearly. This creates a simple rule-based chatbot system. After completing the chatbot logic, I focused on the user interface design. I used IPY widgets, HTML, and CSS styling to create a mobile application style chatbot interface. The interface includes compact chat bubbles, typing animation, a dark theme, and a quick access topic button. The update chat function handles displaying users' messages and chatbot responses. The typing effect was created using time sleep. This adds a small delay before the chatbot response appears, making the interaction feels more realistic. Next, I created the create mobile frame function. This function is responsible for designing the main chatbot container. It controls the chatbot layout, colors, borders, spacing, and scrollable chat area. The interface was intentionally designed to look similar to a modern mobile messaging application to improve readability and user experience. I also added interactive quick action buttons for common topics such as bills, AC, lighting, and devices. These buttons help users quickly interact with the chatbot without typing full questions. The buttons was created using wedges button function and connected to the chatbot intent using the on-click function. Finally, all the chatbot components were displayed together using the display function. This includes the chatbot title, description, input box, send button, quick action button, and the chat container. I will show how the chatbot works. In conclusion, this project successfully demonstrates how Python can be used to build the interactive chatbot system. The chatbot can identify user queries, respond to structured answers, and provide useful recommendations related to household energy usage. One of the main strengths of this project is the combination of functionality and user interface design. Features such as typing animation, chat bubbles, and quick access buttons help improve user interaction and usability. In the future, this chatbot could be improved further by integrating artificial intelligence or natural language processing models to support more advanced conversation and personalized recommendations. Thank you.